So I will start off the session by answering some questions first. Then feel free to ask any questions. After that, we may highlight some important points about hypothesis test. Okay. So the first question I get, it is module 4. Okay, module 4 questions. Can anyone see the question? Maybe not. I'll try to make the font bigger. Okay. So I will read aloud about the question. The question is, the TTC has set a bus mechanical reliability goal of 3,800 bus miles. Bus mechanical reliability is measured specially as the number of bus miles between mechanical road courses. Suppose a sample of 100 buses resulted in a sample mean of 3,850 bus miles and a sample standard deviation of 175 bus miles. Complete. The question I got is, how do you compute the test statistic? Okay, and how do you compute p-value? That is the question. Okay, so I'll highlight the important numbers. You got sample size 100, sample mean 3,850, sample standard deviation 175. The question is, how do you calculate the test statistic? That is the question. Okay. So when you do the test statistic, some students confused. Do I use z-test or do I use t-test? Okay. For this question, sample standard deviation is given, you use t-test. Okay. So the test statistic t equal to sample mean minus population mean mu divided by sample standard deviation over square root of sample size. Okay. And in this question, sample mean is 3,850. Okay. 3,850 is the sample mean. Population mean mu is this one here. 3,800, that is the population mean. And then divided by S over square root of n. Sample standard deviation 175, and then square root of sample size 100. Okay. And you can quickly do this calculation, and this is 50 divided by 17.5, because square root of 100 is 10, okay? So what is 50 divided by, hold on, sample mean 50, 10, yes. So I'm going to use Excel to quickly do that number. So that number I need 50 divided by 17.5, I got 2.857, okay. 2.857. So that is the first question I get. How do I calculate the test statistic? Okay. The second question I get is, what is the p-value? How do you calculate the p-value? Once you get this test statistic, I will put my calculator here. You calculate p-value by press F5, F2, F2. Okay. So F5, F2, and then F2. After that, you have lower. This test statistic is lower, so you type in 2.857 is the lower. Upper is 10,000. DF, degree of freedom, oops, is the sample size 100 minus 1, so 99 is degree of freedom. And then you press EXE, you will get p-value equal to, okay, scientific notation, 0.0026. Okay. So based on this test statistic, you get a p-value. Okay. Because this is a two-tailed test, the final p-value you have to multiply by 2. The number you get from calculator, you have to multiply by 2. This is because when you use calculator, you said this is your lower bound test statistic 2.857. Okay, and upper bound, you use a very big number, 10,000. The number you get from calculator is this area. Because this is a two-tailed test, you also have another area. So you have to multiply the result from calculator, multiply by 2. You get the final result for p-value, 0.0052. Okay, so this is the questions. Based on p-value method, obviously you reject the H0. By the way, what is H0? What is H1 for this question? Anyone has ideas? What is H0? What is H1? H0 said the mean is mu is 3,800. H1 said it is not, mu is not 3,800. Okay, so that is H0, H1. And based on p-value method, this p-value is smaller than alpha. Alpha is 0.01 here. When alpha, p-value smaller than alpha, reject H0. Reject H0 in favor of H1. So your managerial conclusion, the mean bus miles is not 3,800. Okay, the mean is not 3,800. Any questions for this one? So this is one question. And the other question.
Sorry, how did you find the critical values for the first question?
Thank you so much. How do you find critical value? Okay, so we found test statistic, we found p-value. Question 3, how do you find how do you find critical value? Okay, because we use a t-test to find the critical value. I will write down the answer here. This is number 3. How do you find the critical value? You use your calculator, do F5. Start with F5. Okay, I'll pull my calculator. F5, and then F2. F2. After that, F3. So I repeat, F5, F2, F3, and now area on your calculator, make sure data is variable. Area, you have to use alpha, critical value. See, alpha is given. Alpha is 0.01, okay? So area is half alpha is area. Area, when you have a two-tailed test, area equal to half alpha. When alpha 0.01, half alpha 0.005. That is area. Okay, so 0.005. Typing into your calculator. I'm not sure if you can see my calculator here. Yeah. Okay. Area 0.005. Okay. And after that, degree of freedom is 99. Degree of freedom is 99. Okay. And then you press EXEK.
Thank you so much. I understand.
Oh, thank you so much for asking. And you get 2.6264. Okay. And you got 2.6264. This is the critical value. Read instructions depending on how many digits you need it. Okay. So this is a question, this question. So now, any other students about this question? Oh, by the way, this question is very, very fundamental. So how do you find test statistic? How do you find p-value? How do you find critical value? Very fundamental in hypothesis test. Okay. All right, so next one, this question. The question is, I will read the question. I'll try to make the font bigger. Try to make. By the way, this is, again, this is module 4, question 4. Module 4, question 4 question. Try to make this font bigger. Maybe you cannot see it, a little bit blur. I will read question. According to a recent report, 46% of college student internships are unpaid. A recent survey of 80 college interns at a local university found that 38 had unpaid internship. Use 0.01 level of significance to determine whether the proportion of college interns that are unpaid is different from 0.46. That is the question, okay? So the question I get is why we do not use standard deviation for this test. The short answer is this hypothesis test is about proportion. The standard deviation embedded into the test statistic. So first, I will show you the test statistic for proportion problem. Remember, in proportion problem, you always use z-test, not t, always z-test. The formula is z equal to sample proportion p, p represents sample proportion, minus population proportion pi, okay, divided by square root of pi times 1 minus pi over sample size, okay. The question, why not use standard deviation? Remember, here when you use t-test, we use standard deviation, see? Sample standard deviation, okay? But why there is no standard deviation? Actually, this part is kind of like the standard deviation here, but we don't have the name standard deviation for proportion, okay? So this is what is the test statistic? Okay, it is Z. And then what is the P? P is sample proportion. See, out of 80 college students, 38 has unpaid internship. So P equal to X over N. X is number of people having some characteristics. N is the sample size. Okay, so you got a P. And what is pi? Pi is the population proportion. This number 46%, that is pi. 46% is pi. Okay, so you have a p-value 38 over 80, and pi 46% is the same as 0.46, and divided by square root of 0.46, multiply 1 minus pi means 0.54. Okay. And divided by sample size 80. So this is your test statistic for Z. Okay, test statistic for Z. And once you get this, I'm going to use Excel to quickly get that number. I will maybe use I will use this cell to do calculation. So on numerator, it is bracket 38 divided by 80 minus 0.46, okay, divided by square root of 0.46 multiplied by 0.54 divided by 80, closing bracket, okay. So test statistic, I get 0.2691, okay. This is my test statistic, okay? So we answered this question. What is test statistic? Next question, what is a p-value? What is a p-value? So I'm going to show you on my calculator, okay? P-value, so this is your calculator home page. You press, if I can do this. P-value, you press F5 button. F5, okay, and then you press F1, and then you press F2. So summary steps, F5, F1, F2, okay, and then you have, again, lower. This test statistic Z value is lower, okay, you type in 0.2691. Yeah, this is your lower, okay, lower. And then upper is 10,000, okay. Because we are using standard normal distribution, sigma is 1, mu is 0. Okay, sigma is 1, mu is 0. And then you press EXE. Okay. You get this number, P equal to 0.39. Okay. Because this is a two-tailed test, we have to multiply by 2. This number multiplied by 2 is the p-value. Okay. So I get, so p-value equal to 0.3639 multiplied by 2. Okay, so you know how to get the result. Okay, and this p-value is greater than alpha. See, alpha is 0.01. This p-value greater than alpha. When p-value greater than alpha, do not reject H0. When p-value greater than alpha, do not reject H0. But what is H0? H0 said population proportion equal to, here, pi equal to 0.46. H1 said population proportion pi not equal to 0.46. Okay, so that is this question. Any questions about this question? Hypothesis test about one population proportion. Any questions? All right, so I'll move to next one. Again, I get this question from students. So the question is, how do you find p-value with calculator? I just showed you, okay? If you have z-test statistic 2.5, okay, you go F5, F1, F2. Oh, by the way, this is from your textbook, so read textbook carefully, okay, and slowly. And then lower 2.5, upper is actually, usually I type in 10,000 on safe side. Okay, sigma is 1, mu is 0. Okay, and then you get this value from your calculator. Depending on if it is one tail, this is your final p-value. If the hypothesis test is one tail, this is final value. If the hypothesis test is two tails, you have to multiply 2 by this value. That is the final p-value. Okay. Any questions? And another question, yeah, so that is the question I get from the past week. Now I open the floor up. Feel free to ask any questions. And then I may highlight maybe module 5. Oh, any questions? I will do. So actually, this is our online modules. So we did some question about module 4. Module 5 is about hypothesis test for population proportion. Module 6 is 2 population means independent sample test. Okay. And then module 7 is 2 dependent samples. I'm going to pause a moment to see if you have any questions. Any questions?
Sorry, I have one more question.
Sure.
How can you tell if it's like one-sided tailed or like double-sided, like in the question?
Thank you so much. Thank you so much. The question was, how do you know it is one-tailed test or it is a two-tailed test based on given question? Okay, so now I'm going to give you some questions. We learn from the questions, okay? So I'm going to give you some questions. I want to type. Why I cannot type? I have to close this, okay. Hope I can type. Okay, I'll try to make the font bigger. So I claim the average age is older than 23 years old. Okay, this is my statement. This is original question. So how do I, based on this one, to know it is one-tailed test or it is two-tailed test? If you have keyword older than, younger than, greater than, smaller than, that usually is an indicator of one-tailed test. Okay, remember this. If original question has older than, younger than, greater than, less than, more than, enhanced, etc., those are one-tailed tests. And based on this statement, how I am going to write down what is H0, what is H1? Remember last lecture, I tell you, H0 always connected with equal or greater equal or smaller equal. H0 can only be select one of those. H0 only show up in equal sign or greater equal, smaller equal. And H1 only have not equal or smaller or greater. And H0, H1, you have to pair them together. These two always pair together. And these two pair together. And these two pair together. Okay, usually is this combination. And the keyword always apply to H1 perspective. Okay, and our calculator, when you do hypothesis test, always based on H1. When you select, hey, greater or equal, based on H1, not H0. Okay, calculator. So the original statement, the average age older than 23. So you write down mu represent average age older than 23. Okay, the keyword older than apply to H1 perspective. Okay, if you have smaller than, always H1. If you have more than, H1. Less than, H1. Enhanced, H1. Once you decide H1, you look at this picture. H0 must take this format, greater equal. Okay, so H0 mu greater, oh no, H1 is greater, H0 must be smaller equal. Because we are looking at this pair. Okay, when you have H1 greater, H0 use smaller equal. Smaller equal 23. Okay, so this is a possible combination. Some textbook also do this. Some textbook always consider H0 is equal. So they do H1 mu greater than 23 and H0 mu, they say equal to 23. It is still correct. Okay, this and this, they're all correct. So this is correct, this is correct. Okay, so this is a one-tail test. Now I'm going to give you example of a two-tail test. So the example would be, I will just select this and then make a little bit change. Become my next example. I claim that the average age at Ryerson University is 23 years old. My statement is the average age is 23 years old. Okay, because you do not have keyword older than, younger than, you do not have keyword increase, decrease, you do not have keyword enhanced, weaker. Okay, so it is that is. Which one represent is? So you have is. Which one is it? This set is. Do you agree? This is is. Okay, and this one connected with H0. So you this time you start with H0. Okay, average age mu is 23 years old. And once you decide H0, when you have this is, H1 is not equal. So H1 mu not equal to 23. Okay. Any questions?
Thank you for answering my question.
You're welcome. Any other questions? Now I'm going to, as I showed you before, this is our online modules. So we did a proportion test. So now I'm going to give you some highlight about module 6, hypothesis test for 2 population means, independent samples, okay? So now let's create some questions. So I'm going to give you an overview, okay? Where is my today's slide? Okay, it's here. So this is about, try to type. Hypothesis test for 2 independent sample test, and this is actually t-test. Okay, this actually is a t-test. We seldom use z-test. Maybe start off with the z hypothesis test for 2 independent samples. There is a z-test. When you use z-test, that means when 2 population standard deviation are given. Okay, you use z-test to do what? To compare 2 population means. 2 population means. For example, Ryerson University is population 1, University of Toronto is population 2. You want to compare the average student age at Ryerson with the average student age at U of T. That question, you are comparing 2 population means, okay? From our experience, we know we assume student either at Ryerson or University or University of Toronto. You cannot be both. You say, I'm a student at Ryerson. At the same time, I'm a student at University of Toronto. Most students will not in this situation. Most students, either University of Toronto or University of Ryerson. So we consider those 2 populations are independent, okay? And if the 2 population standard deviation is given, you can use the z-test, okay, z-test. Again, I will use that situation. So I'm going to compare the average age at Ryerson University with the average age at University of Toronto. Okay, so and suppose, okay, so suppose standard deviation at U of T, okay, we are talking about average age, okay, so I omit some context, just highlight. Suppose the standard deviation at U of T equal to, suppose 3, okay, and the standard deviation at Ryerson is 4, just suppose. Okay, so what I'm going to do, I want you to compare the average student age at Ryerson with the average age at University of Toronto. Okay, so you want to draw conclusion about the population, but you have no way to ask each and every student in each university. What you can do, you select samples from each university, okay? Suppose you select 20 students, okay, from Ryerson, and you found the average of those 20 students. The average age is 23 years old, okay? And also you found randomly selected 25 students from U of T. Okay, and you found the standard deviation you found the average age, oh, you found the, with standard deviation is given, you found the average age of those 25 students is 21 years old, just for example, okay? Then I ask you this question, is there a difference, significant difference? Is there a significant difference between the average age at Ryerson and between the average age at Ryerson and the average age at U of T? So anyone have questions about the context, what I am trying to do here? I want to try to compare the population means. There are two population means. How do I compare population means? I do hypothesis test. I select random students from Ryerson. I select some random students from U of T. And I found at Ryerson average age 23 and U of T average age is 21 years old. And I also know the standard deviation at Ryerson is 4. Standard deviation at U of T is 3. So now I ask you a question. Is there a significant difference between the average age at Ryerson and the average age at U of T? Anyone understand what is the given numbers and what is the question here? Okay, good. So how do you answer this question? As you go over some hypothesis test, usually we have 5 steps, either critical value approach or p-value approach or confidence interval approach. We use 5 steps. So step 1, always step the null and alternative hypothesis. Okay, so in this case, can anyone try what is my H0? What is my H1? Anyone want to try? How do you write down H0? And how do you write down H1? See the keyword difference. The keyword difference, you go back, I told you, out of these symbols, where is the difference? Not equal is different. Is similar to different, okay? So the question asks you, population 1, suppose Ryerson is population 1, mu1, different from population 2 is U of T. So mu1 not equal to mu2. That is your H1. And H0 is the opposite of H1. So those two population means are the same. Is that clear? All right, so that is step 1. And step 2, always stat alpha. Step 2, specify alpha. Alpha usually is given. If alpha is not given, you use 0.05. This applies to final exam. If some questions do not give you alpha, but you need alpha, use 0.05, okay, as alpha. So I'm going to add, is there a significant difference between at 0.05 level of significant? Just simple form, 0.05 level. So step 2, alpha, okay. Alpha 0.05. And step 3, usually it is calculate test statistic. Remember test statistic, it is just a formula, okay? And in this, usually it is a t-test or z-test. So far, you do not have any other test. So far, you learned either t-test or z-test. Remember the difference between t-test and z-test is that when population standard deviation is given, you use z-test. When population standard deviation is not given, you use t-test. Okay, and this question, population standard deviation is given. See, suppose standard deviation at U of t. Nothing mentioned about sample. So those are the population standard deviation. Okay, so you use z-test. Okay, this is the first time we are encountering two populations. So it is a new formula. The formula said sample 1 average minus sample 2 average, okay, minus population 1 mu1 minus population 2 average mu2, and then divided by square root of population 1 standard deviation squared divided by sample 1 size plus population 2 standard deviation squared and divided by sample 2 size. This is your test statistic, okay? And then you plug in the numbers. So x1 bar, what is x1 bar? x1, let's say 1 represents Ryerson, okay? Ryerson University. Subscript 2 represents U of T. Okay. So x1, the average age at Ryerson is 23 years old. See, 23 years old. x1 bar equal to 23. Okay. So maybe I'm going to write down here 23. The average age at U of T, x2 bar U of T, 21 years old. 21 years old. Okay. And then minus mu1 minus mu2. If mu1 equal to mu2, that is the same as mu1 minus mu2 equal to 0. Is that right? Okay, so minus 0, because mu1 equal to mu2. So that mu1 minus mu2 equal to 0. Okay. And then divided by square root of sigma 1 square. Standard deviation at Ryerson is 4. So 4 square divided by N1 Ryerson sample size. Where is Ryerson? 20. 20 is N1. Okay, Ryerson sample size. And plus standard deviation at U of T. is 3 here. Standard deviation is 3. So 3 squared divided by how many from U of t? 25. Okay, from U of t. Okay, and then you do the calculation of this one. So I'm going to use Excel. You can double check using your Excel or form. So equal to on the top, 23 minus 21 is 2 divided by on the bottom square root. On the bottom I have square root of 4 square divided by 20 plus 3 square divided by 25. This is on the bottom. So I get test statistic 1.85. Okay, this is my test statistic, step 3. And step 4, found critical value. Okay, I'm going to use this is redundancy. You can stop me to ask any questions. Okay. Step 4, found critical value. And this critical value, correct my mistake. I will make a mistake, okay? Found critical value for t. Any mistake for here? Found critical value for t. Correct my mistake. Anyone? Critical value for t. Correct my mistake. Critical value for z, you have to match. If you have z is your test statistic, critical value must be for z and not for t. Okay, you have to be consistent. Okay, and how do I find my critical value for z? Based on alpha. Okay, so you have to draw a picture. This is two-tailed test. How do you know it is two-tailed? See, this is an indicator. It is a two-tailed test, not equal, okay? Two-tailed test. So alpha 0.05 means this is half alpha. The left tail is half alpha. And this is another half alpha. Okay, so when this is a half alpha, it is 0.0025. Okay, so how do you, based on this picture, to find the critical, where is the critical value? Critical value is this point. What is the value of this point? 0.05, 0.00, no, I have one extra zero here. 0.025. 0.025. Okay, this area equal to 0.025. So now answer this question, what is this point? Okay, so use your calculator. Make sure your calculator is at home page and you press F5, F1, then F3, you are here. You get here by press F1, oh sorry, F5, F1, F3, okay? And after that, tail, see, I have this little right tail, you select right, tail right, area 0.025, okay? Tail right, area 0.025, sigma is 1, mu is 0. Okay, and then press EXE, you get 1.96. Does this number look familiar? Yes. When you have alpha 0.05 critical value, one is negative 1.96 the other is positive 1.96. Okay, so you found this critical value. Step 4. Step 5, compare critical value with test statistic. Okay, to compare, you locate. This is your test statistic 1.85. It must be here, smaller than 1.96. Okay, so your critical value test statistic maybe 1.86. Okay, so this is your test statistic 1.86. Obviously, this test statistic is not in the rejection region. So do not reject H0 because test statistic is not in the rejection region. Where is rejection region? Critical value decide rejection region. So this is rejection region. Okay. The green area is the rejection region. And there is another rejection region here on the left tail, rejection region. Your test statistic here is not in the rejection region. So you do not reject H0. Do not reject H0 means H0 is correct. Means the average age at rhizome is not significant different than the average age at year of t, the final conclusion. Is that clear? So that is the hypothesis test about two population means given, population standard deviation are given. But in real life, you do not have a standard deviation for population. You only have a standard deviation from sample. And in that case, you have to use a t-test. Okay. Most popular t-test, we use a pooled, we call pooled variance. We use, okay. We have this new concept. To do what? To compare two populations means when population standard deviation is not given, but you know sample standard deviation. So you use a t-test. Okay, and t equal to x1 bar, sample 1 mean minus sample 2 mean, and then minus population 1 mean minus population 2 mean. Okay, and then you have on the bottom, it is complicated, okay? It is a complicated formula. You can check out on the textbook. Sample 1 size minus 1. You use t because you know population sample 1 standard deviation is s squared. And then divided by sample 1 size plus sample 2 size minus 2. Minus 2, okay? And then plus N2, sample 2 size minus 1, sample 2 standard deviation squared divided by N1 plus, let me see, this one, degree of freedom, that's one. Different format, SPO, you can use this short, simple format. This is a little bit complicated. If I introduce pooled variance, so I'm just going to use pooled, this SP square represent pooled variance, and then multiply by 1 over N1 plus 1 over N2, okay? And then what is SP square? Okay, SP square is pooled variance. So SP square equal to N1 minus 1 sample 1 standard deviation square plus sample 2 size N2 minus 1 times sample 2 standard deviation square. And then over N1 plus N2 minus 2. That is the pooled variance, SP square. Okay. Once you have this test statistic, you follow exactly the same steps, 5 steps. You can test 2 population means. Okay. So in summary, what we did in this session, I answered some questions about hypothesis test for proportion. Specifically, we calculated test statistic, we calculated p-value, we calculated critical value. And we also started hypothesis test for 2 population means using 5-step critical value approach. Okay. We have maybe just 1 or 2 minutes. Any last minute questions? All right, that's all for this section. Thank you so much for attending. I love your questions and I look forward to see you next Saturday. Good night.